If you've ever compiled a program, got errors, recompiled again, expecting they magically disappeared, hit that like button. Alright, so my name is Jose. Welcome to Algo Runner. Today, what we're gonna do is we're gonna do some linear regression, but this time using Keras. If you haven't checked out my last video, go ahead and do that right now. We went over linear regression, but we used Tensorflow's core functions to do that and to get a better understanding. We're gonna be converting Celsius into Fahrenheit using TensorFlow 2.0. So from now on, we're gonna be using TensorFlow 2.0, and by default, Keras is the default higher level API for that. And so let's take a look at that formula. So to convert Celsius to Fahrenheit, we need Celsius times 1.8 plus 32. That's perfect. That's a linear regression model that we can come up with. So 1.8 would be our expected weight, and then 32 would be our bias. Jumping into Colab here. So I went ahead and I used this try except block that I grabbed from TensorFlow's website, just so that we can make sure that we're using TensorFlow 2.0. So executing that, we have TensorFlow, NumPy, Matplotlib, some of the libraries that we'll be using all the time. Okay, so here I have a data set that I went ahead and picked from this list here that this website provides. Celsius will be our input and Fahrenheit will be our output. So this is some of that data that we're going to be using to train the model. Okay, so to use Keras, we're going to define our layers, our layer 1. This model is a linear regression, so we'll only need one layer. We're going to go ahead and define that as L1. We use TensorFlow, Keras, .layers, and then we're going to use the dense layer. And next video, I'll go ahead and go into more depth into what layer or a dense layer is. So stay tuned for that. Please subscribe and stay tuned. We'll use 1 unit. And then what we need is to define the shape. So input shape equals to 1. All right. Oop. Units. Yep. Okay. So now we're going to be using a sequential model from the Keras. So model equals TensorFlow Keras models.sequential. Sequential. Okay. So sequential takes a list of layers. In this case, we only have one layer, L1. Take that in. Okay, so now we need to define our optimizers and our loss functions. All right, so we're gonna use, model equals, okay, so model dot compile, and then we have our optimizer, and then we're gonna use optimizers, and then it's Atom. So we're going to use Atom this time around. I'm going to use a learning rate 0.1, and then we're going to go ahead and define our loss function. So our loss function is going to be the same loss function that we used in the last video. If you guys haven't done so, check that out. I give an explanation of what this loss function is, the mean squared error. Go ahead and do that. Come back over here. So all right, so mean squared error. Okay. All right, awesome. We got our layers. We defined that we needed a sequential model, and then we defined our optimizers and our loss function. Now we're ready to train. So model.fit. We're gonna feed it in our X, which is our Celsius, because we're trying to convert Celsius into Fahrenheit. Our Y, or our output, is gonna be our Fahrenheit. That's the data set we're using. And then epochs, we're gonna go ahead and use 500 epochs. So that's 500 iterations of the gradient descent, or our optimization. And let's get this guy going. The history. All right, so now we're training. Okay, so remember, what we're expecting is a weight to be around 1.8 and bias to be 32. So after the 500 iterations, that's what we're expecting. So what we're gonna do is we're gonna go ahead and go into our first layer and check out the weights. And it's what's cool is Keras outputs that in a list, I believe, or some kind of NumPy array. So it looks like it's done now. Okay, so let's take a look at the weights here. So to do that, to L1, which is our layer, our dense layer that we got, and then we use the get weights. So let's check the output out. Pretty cool. All right, so the first one is 1.8, which is our weights, which is 1.8, pretty close. And then our bias, it got 28.29, which is pretty close to 32. So let's do some predictions here. So let's use our model to predict what 100 degrees Celsius is in Fahrenheit. So the predict function is expecting a list of inputs because the way it does is you feed it in batches in order to do some kind of prediction. So just feed it in a list of, and then 100 as Celsius. So let's see our output, and our output is 214 degrees. So if we go to Google and do 100, it's 212. So let's go back. What do we get? 214. That's pretty close. So there it is, guys. That's it. I just want to make a short, quick video on Keras because that's what we're going to be using on our next video. So stay tuned for that because we're going to be doing some classification. So check that out. Please go ahead and subscribe. Hit that like button if you guys liked it, dislike, whatever. Let me know how I'm doing. All right, guys. Have a good one. Lates.